The Kenyan teacher here one more time. This time we have the pleasure to present a video on tests involving inorganic substances. Welcome and stay on till the end. We begin with questions that ask a candidate to describe the appearance of a substance, especially a solid. So in such cases, color and texture of the solid must be included in the description. Now, solids come in different textures. Some are in form of crystals. I believe candidates, you know what we mean when we say or when we talk about a crystal. Some solids come in powder form. Others are filings. We do have granules, tannings, ribbons, and pellets. So if you're asked to describe a solid, we can have examples that may include white non-crystalline solid. So here white is the color, non-crystalline is the texture. We may also talk about a white powder. Powder texture, white color. And things like blue crystals are also allowed. Now, if a candidate talks about just a substance being a solid on its own, this is usually rejected. We also have on the list of rejected descriptions, colorless crystals, white precipitate, white solution. These are some of the descriptions that our candidates give to the solids provided. So all these will not be accepted. On the list, we also have shiny crystals. We shall not accept that as well. Now we proceed to our test number 2, and this is on the expected observations and inferences a candidate can make when we are asked to heat substances. When heating a substance, common expected observations and inferences may be as follows. So number 1, a candidate may observe a colorless liquid forming on the cooler parts of the test tube. This observation may be replaced by colorless vapor condenses on the cooler parts of the test tube, or droplets form on the cooler parts of the test tube. These are the only 3 acceptable observations that a candidate can make. Now, we have a very common observation made by students, but I want to inform our candidates that when we talk about moisture forming on the cooler parts of the test tube, this is an acceptable observation because we cannot be sure that whatever is forming on the cooler parts of the test tube is moisture. Other candidates also talk about colorless liquid condenses on the cooler parts of the test tube. This is chemically wrong. Liquids don't condense. It is vapor that condenses. So if we see this observation, the expected inference is supposed to be that the solid we are provided with is hydrated. Or we can also talk about the solid we are provided containing water of crystallization. So if a candidate observes colorless liquid forming on the cooler parts of the test tube, then the expected inference would be those two that we have just tabulated. We are still on heating substances, and we continue to look at expected observations and the acceptable inferences that a candidate is supposed to make. Now, if a candidate observes, and this happens when the instructions are clear, that as you heat, then you put some moist blue and red litmus papers at the mouth of the test tube. So if we observe red litmus paper turning blue and blue litmus paper remaining blue, the inference that a candidate should make is that your salt contains ammonium ions. It happens that ammonia gas is the only gas that is alkaline in nature. So if your red litmus paper turns blue and blue litmus paper remains blue, then it means that the substance you are heating actually produces ammonia gas, and for that matter, the solid must have ammonium ions. Now, if this time round blue litmus paper turns red and red litmus paper remains red, this time round the substance actually produces an acidic gas, and because acidic gases are quite many, we will now allow a general inference that the gas being produced is acidic. We are still on expected observations and correct inferences that we are expected to make when heating substances. Next, if a candidate observes a white solid turning yellow on heating and the same solid turning white on cooling, candidates, don't forget, this describes zinc oxide. So if you see this kind of observation when you are heating your solid, we can infer that the solid contains zinc ions. This second one, where white solid turns red or orange on heating and yellow on cooling, this describes lead oxide, and for that matter, we shall infer that your solid contains lead ions. And when it is present, you can leave the ion on its own without writing the word present, or you can go ahead and write the word present. Both are acceptable. We continue, and we are still on heating a substance. The next observation a candidate can make when heating a substance is production of a colorless gas that extinguishes a burning splint. This must obviously be either sulfur 4 oxide or carbon 4 oxide. So the inference we are supposed to make here is that your salt contains carbonate ions that produce carbon 4 oxide when heated. Now, some of these heating processes are usually accompanied by some sound being produced. So during heating, we expect candidates to talk about decrepitating or crackling sound. But cracking sound has been so common in our candidates. Please get to know that we only allow decrepitating or crackling sound, and cracking sound is normally rejected. Cracking sound would mean that your test tube actually is breaking, and that is normally not the case. We are through with heating substances. We've looked at expected observations and the corresponding inferences a candidate is supposed to make. Let's now move on to solubility of substances in water. So when a candidate is asked to add water to the solid and make observations and inferences, we have a few of these expectations. Number one, the solid may dissolve in the water to form a colorless solution. Common mistake candidates make is that solid dissolves forming colorless liquid. It has to be solution because this is a situation where you are dissolving a solute in a solvent. The result is not a liquid but a solution. So get to know that, candidates. If you see this observation, the inference is supposed to be that solid is actually soluble in water. We can also go ahead and be sure, because we are forming a colorless solution, we can be sure that copper ions, which would actually produce blue solution, ion 2 ions, which would give green solution, and ion 3 ions, which would give brown solution, are this time round absent. And this inference we make because our solution is colorless. Second, we can be asked to filter. If we see that on filtration, we get a white residue remaining on the filter paper and a colorless filtrate being collected, then the correct inference would be that solid is sparingly soluble. Solid is sparingly soluble. Or, because we are forming a colorless filtrate, we can also go ahead and conclude that copper ions, ion 2 ions, and ion 3 ions are absent. Many candidates make a mistake that if you see this observation, we normally infer that that the solid is a mixture of soluble and insoluble compound or salt. Take note that this would be denied that mark. The only acceptable inference is that the solid is sparingly soluble. We proceed now to flame tests. When it comes to flame tests, yellow flame would mean sodium ions are present. Lilac flame, as usual, would mean potassium ions are present. Pale green represents barium ions. Red is calcium, and colorless flame is for magnesium. Here, we normally confuse colorless flame with white flame. So candidates, take note, it is colorless flame, not white flame. Let's proceed now to addition of sodium hydroxide solution. Addition of sodium hydroxide is a very common test, and we once did a very conclusive video on the same. So when you see a white precipitate which is soluble in excess, please remember ZAP. Zinc present, or aluminium, or lead. These we normally remember with ZAP, Z-A-P. Now, when we see white precipitate insoluble in excess, then this time round we have calcium present, or magnesium, or barium. In the video that we did, we explained why these observations are expected with the associated equations clearly explained. Now, when we see no white precipitate, then it means all these 6 ions which would otherwise give white precipitates are absent. So this time round, we would say that zinc, aluminium, lead, calcium, magnesium, and barium, these ones would be absent because we are not seeing any white precipitates. To now aqueous ammonia, or what we normally call ammonium hydroxide. This substance has those two names. So if you are asked to add ammonia and on the bench you don't see ammonia, you don't see aqueous ammonia, instead your teacher supplied you with ammonium hydroxide, please, it is one and the same thing, either aqueous ammonia or ammonium hydroxide. So this time round, white precipitate soluble in excess, again we explained in our previous video, this is zinc. White precipitate insoluble, we would have now aluminium, lead, magnesium, and barium. Now, no white precipitate. This we say calcium. But there is a condition. The condition here is that ammonium hydroxide test may come after sodium hydroxide. So it may be a confirmatory test. So we will accept calcium if you don't see white precipitate only if while using sodium hydroxide on a test that may be before this one, that is when we will accept calcium. We will accept it only if while we are using sodium hydroxide, then we must have said somewhere that calcium, magnesium, or barium are present. So that is the only case where we shall accept calcium to being present here. If you didn't infer this before, so if not, then no white precipitate would mean aluminium, lead, magnesium, barium, zinc absent. So I want you to take note of that if you don't see a white precipitate, if we are using ammonium hydroxide, we will allow calcium present only if while we are using sodium hydroxide, we had indicated that calcium, magnesium, or barium are present. Otherwise, if you didn't write that while using sodium hydroxide, then calcium being present here would be a contradiction. Let's proceed now to addition of nitric 5 acid. So if we add nitric 5 acid and we observe effervescence, fizzing, or bubbles of a colorless gas, I know most candidates would want to use these words which are not accepted. Hissing sound will not be accepted. Fizzling sound is also not accepted. It's fizzing, not fizzling. Others also talk about white precipitate. Remember, all nitrates are soluble. So we cannot use nitric 5 acid and get a precipitate. That is chemically wrong. So in this case, our inference would be that your salt probably contains hydrogen carbonate ion, which would now give out a gas with the acid. Carbonates would also have effervescence with the acid and even sulfite. So those are the acceptable inferences that we can make. Let us continue to a situation where we are told to dissolve our solid in either hydrochloric acid or sodium hydroxide. Remember, hydrochloric acid is an acid and sodium hydroxide is an alkali. So if in hydrochloric acid your solid dissolves forming a colorless solution, if we see this, our inference would be that your substance that you are provided with is basic. That's why it's able to react with or dissolve in the acid. If now you're provided with an alkali and the same happens, then this time round the substance you are provided with is acidic or maybe amphoteric. Let's proceed to addition of sodium sulfate, which would introduce the sulfate ion into your solution. Observing a white precipitate here would mean calcium ions, lead ions, or barium ions are present. Remember, these are the insoluble sulfates, and that's why we are able to see white precipitate. Now, on the other hand, if we don't see any white precipitate, then we will infer that magnesium ions are present. However, for this to hold, we need to say that this is a confirmatory test. This is normally a confirmatory test, which means it's a test you are doing after doing several others. So, on preceding test, if you have to infer that magnesium is present, on preceding test, you must have inferred that calcium, magnesium, or barium present must have been inferred for this inference to hold. This we said with ammonium hydroxide, and we are also saying it with sodium sulfate. Let's proceed to using barium nitrate as a reagent. So when using barium nitrate, we can have plain barium nitrate and we can have acidified. Let's begin with plain barium nitrate. If we see white precipitate, then we will infer that sulfate ions, this negative, sulfate ions, sulfite ions, or even carbonate ions could be present. And when you don't see that, then the same sulfate, sulfite, carbonate, this time round, we would infer that these are absent. Now let's continue to a case where our barium nitrate is acidified. For this case, white precipitate after addition of acid would only mean sulfate confirmed, because sulfite and carbonate would dissolve on addition of acid. 4. No white precipitate while using acidified barium nitrate, the opposite of this first one, so we would infer that sulfate ions this time round are absent. We proceed to tests that involve addition of lead 2 nitrate. Remember, lead 2 nitrate introduces lead ions to your solution. So here we have quite a number of expected observations. White precipitate soluble on heating. This would be presence of chloride ions or bromide ions. When we see yellow precipitate, characteristic of iodide ions, no yellow precipitate would mean that iodide ions are absent. Then, if we see white precipitate, this time round we have quite a number of ions. We start with sulfate, carbonate, sulfite, chloride or even bromide are present. And lastly, if we don't see a white precipitate, then it means that the whole group, sulfate, carbonate, sulfite, chloride, and bromide are now absent. To our oxidizing agents now, acidified potassium manganate 7 and acidified potassium chromate 6. So for acidified potassium manganate 7, if the purple color changes to colorless, the inference would be sulfite ions or sulfide ions being present. For the potassium dichromate 6, orange changing to green, the same sulfite present or sulfide present. Now to calcium hypochlorite. Now when you are told to add calcium hypochlorite and we observe the solution changing to brown, which finally forms blue solution on addition of starch, this is test for iodide ions. And if the solution changes to yellow, this is bromide, of course, present. We also have addition of potassium iodide. Characteristic yellow precipitate actually tests for lead ions being present. We are lastly looking at addition of chloride ions. Chloride ions may this time round be obtained from either adding hydrochloric acid, a few drops, or we can even use barium chloride. So if we see white precipitate that is soluble on warming after adding any of these two, lead would be concluded to be present. If we see white precipitate that is insoluble on warming after introducing chloride ions, that would be a sign that silver ions are present in your solution. We are through with our long video where we have taken our candidates through expected observations and inferences when we are carrying out tests on substances that are inorganic. Thank you for your time, and we ask that you keep it the Kenyan Teacher for more reviews.